Hello everyone, myself Shlok Nemani. I am affiliated to Maritime Research Center as a research fellow. Today I am presenting my work on digital transformation for a sustainable blue economy. So here in this presentation, we will be first looking at why is it all important on whatever we are discussing today. So this approach is three-faceted. We are going to understand how people, economy and nature correlates and the interplay between these all factors, how one can strengthen the pillar of sustainability among the three. So, starting with the people, in terms of blue economy, as per the Indian Brand Equity Foundation, close to 30 million people are being employed in the industry of fisheries and aquaculture. Not only that, our current government has launched Pradhan Mantri Matsya Sampada Yojana back in 2020. So, this idea of this flagship scheme PMMSY, it wanted to boost the growth of aquaculture and fisheries in India while also making sure that the productivity of aquaculture is increased, not in terms just of the total outcome, but also by making the lives of the employed people more privileged and making the returns on their investments higher. Not only it brings the sustainability into the growth of aquaculture, but it also focuses upon the leisure and privilege for the farmers by making sure that the adequate skills and knowledge is provided to them. So if we move ahead to the second aspect of economy, so if we talk about how the last decade turned out to be, so we have two aspects if we talk about shrimp as well as seaweed. So in terms of shrimp, if we talk in the last decade, so overall, the production show a monotonically increasing growth, as well as in terms of the total fisheries as well as the aquaculture. It can be seen as the aquaculture production monotonically increased, while the capture production is more or less flat. So even in that, if we currently talk about the total exports from the India, so we already had the all-time high exports of seafood worth USD $8 billion. So that is in terms of value terms. While in terms of weightage, we are exporting around 1.7 million metric tons. Out of all of the total exports, the frozen shrimp is the major contributor to the total exports. Now, if we are focusing on the exports, we also have one species or one organisms which has a potential in the future, which is not currently harnessed. So, as per the director of ICAR and CMFRI, India has the potential to produce around 10 million metric tons of seaweed, and you will be astonished by knowing that currently we just produce about 35,000 metric tons. So there is a significant growth factor here, like the multiplier of how much seaweed which we have the potential to produce and how much we are currently producing. In terms of nature, so we are trying to understand how the impact of fisheries and aquaculture is on the nature and how it manifests itself in the terms of whether there are negative consequences or positive. So, if we talk about the two species, shrimps and seaweeds, and aquaculture, the shrimp aquaculture, so a lot of studies have already shown that the shrimps aquaculture have very harmful effect on the environment, which includes mangrove deforestation as well as saltwater intrusion and many more. But on the other hand, the seaweeds, which are tend called to be the pioneers of sustainability. So this species has positioned themselves at the very top of the spectrum of sustainability, where they have a beneficial footprint on the nature. Not only they can be harnessed to make the value-added products like biofuels, but they are the cultivation of seaweeds not only require a lot of resources in terms of water, but it also helps by polycultivating seaweeds and shrimps where the seaweeds help reducing the chemical content of the water and therefore helping shrimps to have a higher survival rate. In terms of this was all in terms of aquaculture. If we talk about the fishing, so IUU or the illegal, unreported and unregulated fishing is one of the major concerns which is raised by the Food and Agriculture Organization and by the European Commission, the policy known as European Commission IUU program, which is abbreviated as EU IUU program. So this was one of the very flagship step which was taken to combat, deter and prevent IUU activities in the waters. Not only this step by European Commission is welcome, but countries like the US they implemented the state import management program. Even Japan and all came together with the European Commission to implement the steps which are pertaining to their own countries. So, if we talk how the multifaceted UDA framework comes into the picture, So the idea of marine environment, where by having the anthropogenic activities, the benthic biodiversity is taking a hit, as well as even the illegal activities of fishing can include the bycatch, which are already vulnerable. So all of this try to disturb the delicate balance of the marine environment, as well as the all the ecosystem that supports on it. On the other hand, we also talk about the digital transformation for the digital oceans, where we are trying to employ or interleave the technology, the digital technology, for the good of people, nature, as well as economy. So here, the idea is the sensors are able to see much more than what human eyes are able to. So how we can even interleave sensors in the whole aspect of fisheries and aquaculture, where by employing these sensors, we can gain insights into how the aquaculture works, so that the productivity of aquaculture and fisheries can be. So bringing this to our first aspect of digital transformation. So this is the umbrella of digital transformation and how MRC is viewing this digital transformation of fisheries and aquaculture. So the whole idea of digital transformation on fisheries and aquaculture is based on marine spatial planning, as formulated by in our RIAN, it is formulated by Arnav Das, while this MSP is a complete international concept. So here idea of MSP is to justify the allocation of land under aquaculture, as well as also along the lines of IUU program. We also need to allocate the waters, the EEZ, as well as the waters beyond that to the nations, so that the whole capture fisheries as well as the aquaculture market is regulated. If we talk about how we are trying to employ this digital transformation in aquaculture, so this is based on the three-step framework, the 2C, to understand and to share framework. So what the 2C is, the data acquisition and collection phase, whereby employing sensors, which can be like floating sensors, or which can be fixed sensors to the any buoyant surface. So how it works is like these sensors, or which deal with the data acquisition. These sensors, let's say for aquaculture, they can include pH sensor, dissolved oxygen sensor, as well as temperature sensors. These gain the insights, the water quality insights for the aquaculture ponds. In the to understand, we have this very aspect of modeling and simulation, whereby gathering this data from the sensors, we build a model. This model is basically underlying functions, which either can be a equation, or it can be a some kind of model which is built on machine learning. So this model learns from the data, as well as this model, when deployed on the ground, it verifies the its output. So if the output accuracy needs to be enhanced, so the correction needs to be done accordingly. Once this whole iteration of modeling and simulation is done, so that the accuracy is under the limits, then it moves to the to share aspect, where the real-time inputs and the inferences can be shared to the user. And this inferences are actionable inputs, so that the farmers or the aquaculture owners can work on improvising their productivity. If we talk about the objectives of the digital transformation in aquaculture, so one thing, with the use of sensors, it promotes the live monitoring. It also allows for optimization of the water quality parameters in order to improvise the yield, as well as demographic mapping. Will be covered by one of the upcoming interns. So, how aquaculture is contributing to the growth of the on the global scale? So, even aquaculture contributes 50% of the total production of the fisheries. The in Asia, it stands more than 50%, which is roughly 61.2%. India ranks currently third in the total fisheries production, and we are second in the total aquaculture production. So aquaculture demands a lot of land requirement, and to justify the land allocation, you need to bring it under the MSP framework. So how digital transformation works is like it brings social harmony by making justified allocation of the land, ecological sustainability, as well as the intelligent insights which are gained from the digital technology, returns on investment, so that the because higher productivity can result in higher yield and higher returns, and the data in open source, because the research which we are trying to include here will bring more and more source in the open source literature, as well as more and more data in the open source literature. So this APY, or the area production yield analysis, is how we are trying to realize this digital transformation for aquaculture. So not getting deep into this, so area production and yield. So yield is one of the important things. So how we define yield is how much production one is able to get from the area. So if the production can be enhanced by increasing yield by keeping area constant, That is one of the most significant or profound statement, because now you are not at all, now you are less dependent on the area and more dependent on optimizing your productivity. So here in the upcoming slides, we will be going to see some of the results of our research. So we are going to discuss about shrimps and seaweeds pertaining to specific species of them. We have identified an exhaustive list of literature, not limited to this, but which are having the feasibility to be captured by sensors in the available market. While this work began with the ideation from very old work by von Bertalanffy. So we started with this von Bertalanffy growth function, where we translated from length to weight, whereby this von Bertalanffy growth function tried to relate how the environmental factors affect the growth. So we related these environmental factors to the weight of the shrimp, and we established this mathematical function as a model, where we try to say that the set of farm parameters, if we have the set of farm parameters like water quality and stocking density, then we can determine the growth rate in advance just by employing this mathematical function. This is some of the maths that determine how we go ahead with this. These are the results which we obtained by having, we are trying to employ two factors here, temperature as well as stocking density. So here we showed that by employing these two and having a model which is a function basically. So this function is trained on the data from the open source, and we gain that how much will be the total harvested biomass if we have the variation in temperature and stocking density. So it certainly shows that the some temperatures and stocking density are more suitable for the shrimps while others are not. So how this helps for increasing the polyculture and between shrimps and seaweeds is because we, while we have models for shrimp, we also have models for seaweed, and we try to see if the temperature in which the shrimps grow as well as seaweeds grow, are they in close proximity or not. These are our results, which fall in well in the range of the current available results. Our predicted biomass fall in the range of the obtained or the experimented results quoted in the literature. So this is just a gist about the APY application which we have built. So we try to make our APY analysis models as a API, and we have that in backend, and our application, Android application, works in front end. This is a small APY analysis Android app which we have built. So how it helps farmers is, let's say if there are two farms which have varied parameters, farm 1 and farm 2. So what happens if we input the farm 1 parameters in our app and farm 2 parameters in our app? So it gives that farm 1 is operating at a good and good condition, and farm 2 at the bad condition, where farmer 2 loses on the total production. Even though they are focusing on the same inputs, so farm 2 is losing on the production. That's why he is having the low return on investment. So this all about the low wastage and the better governance through APY analysis, where by having the information in advance, the policymakers can have the complete knowledge about how the farms are operating in the whole country, helps them getting the better insights for the policy making. Also, it supports inclusion, because it is said that the while the lot of farmers are involved on the traditional farms where the returns on investment is low, this technology can be interleaved very easily. Only the support from government to employ census is it. So there are certain challenges in the work where we required a lot of structured data for training these models, as well as the hardware complexity, because what we are proposing is a hardware solution along with a modeling and simulation approach. So that requires some support in on the side of farmers to employ these sensors on the ground. Not only that, there are other works which have been covered by our past interns on counting the fishes using the YOLO detection models, and that also supports the productivity idea. So that's all from my side. Thank you for having me.